Welcome to this session of Fibre. We have about 4 speakers, 5 speakers, 5 papers. The first one is the Incineration, wool, Scouring, Sludge, with Dr. Blue, Dr. Gandhi, and Dr. Pearson. We have with us Dr. Pearson. May I ask you just to let him introduce himself to you?
Good afternoon, ladies and gentlemen. It's a great pleasure to be able to address the audience at the Textile Institute World Conference. I'm head of the Department of Textiles at the University of Huddersfield, which is in northern England. My main research activities and teaching activities are in the areas of textile technology, particularly finishing. I'm a member of the Textile Institute Council, the Events Committee and the Professional Education Affairs Committee. I'm delighted to be able to present the paper today on an aspect of our research at Huddersfield.
Thanks, Dr. Pearson. And as our rules, we will have the presentation in 15 minutes, and we will have 5 minutes for discussion and any question.
The technology seems to be working. So the paper is to do with the incineration of wool scouring sludge. If you're not sure what the terms mean, scouring sludge is the residual material following the wool scouring process. During the plenary sessions, many of the speakers were talking about the importance of environmental implications on sustainability. And this is the background really to the work underlying this paper. This morning was mentioned ISO 14000 as an environmental standard. In the UK and Western Europe, we don't just work to that, but there's legislation as well directed by the European Community under what's known as Integrated Pollution Prevention and Control, which is IPPC. And included in this, we see landfills and treatment plants. 2 types of treatment we can offer to waste. Landfill is where you dump the waste on specially designated pieces of land. So originally pollution prevention in the UK was governed separately depending on the type of pollution that's existed. Nowadays we have an integrated programme depending on the level of pollution. The Environment Agency is a national body that directs pollution prevention, and that deals with major pollution sources. The local authority, the local government, deals with lesser sources of pollution in particular areas of the country. The features, the requirements of the EC legislation include the requirement to use the best possible techniques for reducing pollution. Previously, it was to do with preventing pollution where you didn't have to spend too much money. It's not just to do with preventing pollution while operating a site. Once the site has finished, then it must be returned to a satisfactory state. And it's not just to do with chemical pollution. We see that noise and vibration are also nowadays regarded as pollution and must be regulated. The important aspects of IPPC that affect the textile industry, waste management in general is covered, but textiles is specifically mentioned. The pre-treatment or dyeing of textiles, which is the pre-treatment that this paper is concerned with, but also most other chemical treatments of textiles are included nowadays in the European Community directives. So this is skipping and moving around. We mustn't also forget that public opinion is a great driver in the UK and in Western Europe of legislation and what happens in general. And the public are very concerned with what they see, what they meet when they go around, that forms pollution. Chemicals in rivers is a major concern of the public. About 60% of the UK public say that they're worried about chemicals in rivers. And of course this is traditionally an area where textile waste is dumped directly into rivers. Now most of the waste nowadays is dumped onto land. I'm not pressing anything, it's jumping ahead, so I do apologise. I said I'm textile technologies, not to computer technologies. Altogether in the UK, there's about 1 million tonnes of treated waste material that we call sludge. Sludge is the material that remains after treatment. At one time, a lot of this was dumped into the sea. Since 1998, that has been prevented, and now there are two main routes for disposal of sludge in general, either putting it directly onto the land or as a fertiliser, or by dumping it in the land in special designated areas. However, the government has recognised that simply dumping waste material on the land is a great waste of the land and can lead to pollution, and the amount of tax that's charged for landfill, as we call it, is increasing steadily, and over a 5-year period will actually double in value. So landfill is becoming a very expensive option. So it's predicted that by 2005, incineration, that is burning waste material in general, will probably become a major alternative. The other one is putting it directly onto land. Now the problem with wool scouring sludge is that it contains a lot of impurities. So much so that if you try and use it as a fertiliser for agricultural uses, these impurities will harm the land. So incineration, burning it, would seem to be possibly the most useful way of dealing with it. Well, what sorts of impurities are present in the wool that gets into the sludge? The main problems are the added materials that are put onto the wool for identification and also pesticides. So this is what we're trying to do, to dispose of wool scouring sludge, to see if it's possible to dispose of it by burning it. Because in the UK, vast majority of wool that we use is imported, we have very little idea about its past history, in particular, what sort of impurities it contains. And when we analysed the sludge that we obtained from different scourers throughout the UK, we found a tremendous variation in the composition. Even from one company, from month to month, the composition varied. So what we decided to do eventually was to blend the sludges produced from a variety of scourers to try and get a more uniform material to deal with. And we selected 7 local scourers, local to our university in the north of England, and we blended the sludge for investigation according to the amount that was produced per annum. So this was the blend that we actually used. We used to burn it a specially developed incinerator or burner called a rotary kiln incinerator. This consists of a cylinder which rotates the mass of sludge within it. Air is inserted into the sludge to keep it agitated and to make sure that sufficient air is present to be able to burn the sludge. So it's just forward again. We'll leave it at that. We required some supplementary fuel. We used propane, slowly fed into the cylinder to keep the burning going. We needed to monitor what was being produced from the incineration, and these were the main gases that we examined in the output. We analysed the sludge before we burnt it to see what it contained, and then we were able to analyse the ash, the remnant of the burnt sludge, to see what it contained. And these were the parameters we looked at in the initial sludge, and we looked at particular elements. believing that these were ones that might cause problems either in the effluent from the burning or if they remained in the ash. This is a very complicated slide, but what it shows is, this is a summary of our evaluation of the sludge to show, if you look at the coefficients of variation and the ranges, they show there are huge differences between the compositions of the various types of sludge for many of the components. And looking at the elemental, the heavy metal content, we saw that there were quite high amounts of certain elements, but again these varied. For instance, the manganese component, there was 13 times as much manganese in the highest manganese component sludge as the lowest. So huge variation, therefore we needed to blend it. So what did we get out of the sludge when we burnt it? These were some of the elements, the gases that we looked at. The carbon dioxide level was satisfactory. We were comparing this against European Community limits, the legal limits that we had to comply with. Carbon dioxide was okay. Carbon monoxide was very high, and that was actually outside the European Community limits. So it means if we have to use this system of incineration, we need some after treatment, an afterburner, to treat the carbon monoxide to convert it to carbon dioxide, and that would still be within the limits. The nitrogen oxides were okay. We looked at sulfur dioxide, hydrogen chloride, that was okay as well. One problem, volatile organic compounds, VOCs, they were slightly higher than the European Community limits, so again the use of an afterburner would be needed to destroy those. Because of the pesticides that tend to be used in sheep dips, we were concerned there might be dioxins or furans present. We found that after incineration there were no dioxins, no furans. So that was a great relief. We looked at the amount of heavy metals remaining after incineration. This is the percentage reduction, and we see that apart from nickel and to a small extent mercury, the vast majority of the heavy metals are destroyed during incineration or removed from the sludge. It's clear they're not broken down into anything else. They must come out with the effluent gases from incineration. We cannot let them escape into the atmosphere, but the use of some sort of scrubber system, which is well established in incineration of domestic and industrial sludge, would satisfactorily remove all these elements. But the good news was that in the remaining ash, the level of heavy metals was so low that the remaining ash could be used for further purposes. We looked at the amount of pesticides present in the scouring sludge itself, and there were quite considerable amounts. Because the wool came from all over the world with no control of the amount of pesticide that was in it, the scourers accept what they find. And these are quite heavy, at quite high levels. But luckily we found that the temperatures in incineration, in this rotary kiln, which were between 600 and 900 degrees Celsius, were insufficient to destroy all these pesticides. There were no pesticides at all remaining in the ash, and none were found in the effluent gases. The temperature was high enough to break all these down into relatively harmless compounds. The mass reduction of the sludge, one of the problems of just dumping the sludge on the land, it's a very wet material and occupies a large volume. After incineration, we found that there was nearly a 90% reduction in the mass and volume of the sludge, so it's a much smaller quantity to deal with, and so it was easy to deal with. The efficiency of combustion in this incinerator was very high. It was nearly 100%. So in other words, virtually all the material that was put into the incinerator was burnt. Now, it's okay if incineration will burn the sludge, but if it's a very high price, then the process is not economically viable. So we did an economic assessment as well, looking at what is happening at present, landfill, putting the waste on the land, and we looked at buying the site, developing it, using it, and then restoring it to its original state. And for landfill, with regard to sludge, it was around about £25 per tonne. Looking at an incineration plant, we found that the overall cost was maybe 50% more. So that may be regarded as being prohibitive. However, an advantage of incinerating the sludge is you can use the heat to generate it, and this will reduce considerably the overall cost. So round about £30 a tonne. So it may be still a little bit more expensive than landfill. However, the actual volume or amount of sludge produced was about 30,000 tonnes of wool scouring sludge produced each year in the UK. And that compares with the figure I gave initially, about 1 million tonnes of overall sludge. And that will rise to about 1.5 million tonnes in a few years' time. So the next stage is to look at blending the wool scouring sludge with overall industrial sludge. Instead of building a new incinerator, is to burn it, incinerate it in existing incinerators. And this we will be looking at in the next few months in an incinerator in the north of England. And doing that, the overall cost of incineration will be equivalent to that of landfill. So looking at what we found, the level of gaseous emissions, what we produce from incineration, is relatively safe, particularly if we have the after treatments. The combustion is a very efficient process. You've got a very small amount of material left. The particular incinerator we used was extremely efficient in doing what we intended it to do, but we needed this after treatment. But these after treatments are common in incinerators that are used in industry in any case. These were the sorts of compounds that we had to have treated. We couldn't allow those to escape in the effluent, but when we do our final trial, we'll find how successfully the commercially available after treatments are in removing these contaminants. The residual ash has a very small volume, easy to deal with. There were no pesticides present in the ash, no dioxins or furans, so the ash is something that can be used. And if this is the case, this will further reduce the overall cost of incineration. You'll get the energy from burning, and you'll be able to sell the ash for these types of products. And indeed, a further aspect of the work we're doing is looking at the use of the ash, not just for land spreading, but as a fertiliser material. So it's looking as if the whole process is a great possibility and could be taken on board by UK scourers. We work with them, they're very pleased with the results. The government, as UK government, has sponsored this research and they are interested in the results. And I hope that it may be a technology that may be of use to other scourers throughout the world. So thank you for listening. I hope you found what I've said to be useful and maybe stimulating. Thank you very much.
Any questions?
Dr. Kartush from the National Research Center. I would like us to that about the economy of the process from the point of view of heat coming out from the incineration, because I read that PMK, they were the first who started this incineration, or part of the French people. I have visited once in 70s or 75, something like that. They were incinerating also their slugs. And the MBK, they said that they receive energy from the incineration much more in value than the loss in heat, in evaporation, and so on. What about the conditions in the UK? You have the same results, or because as I understand that the landfill is a little bit cheaper than incineration, meaning that you are losing by incineration?
Well, at the moment, landfill is cheaper than incineration because of the point I mentioned earlier, the UK government landfill tax will be doubling in the next 4 or 5 years. So that £25 per tonne figure that I mentioned will increase. and as more and more waste in general will be incinerated, the cost of incineration will decrease. So there'll be a point when the two become more or less equal in cost, and eventually I'm sure the cost of incineration will be reduced. But we did realise that in the UK there isn't enough wall scouring sludge to incinerate on its own. It would have to be mixed with other industrial and domestic sludge. But there seemed to be some sort of, in the pilot work we've done, there seemed to be some sort of synergy in this process. So we've got a very efficient mix. And the next stage of the trial, to do it in a full-scale incinerator, should hopefully prove just how much saving we can get from the heat compared with the present landfill costs.
It may also depend on the amount of sludge, or I mean solid material in the sludge.
Yes.
Including, of course, the wool grease.
Yes, well,
you have wool grease and salts and so on.
Well,
and what is the concentration of the sludge?
Sorry?
The concentration, what is the solid content of the sludge compared to the water? Because you have to evaporate water and then before incineration.
Yes.
So you have to evaporate water completely till having a concentrated sludge and then you incinerate.
This is another aspect. There was a huge variation in the water content of the sludges, and this is another reason for blending it. I'm trying to find the slide that showed the water content. But we found using this rotary kiln incinerator, we didn't need any pre-drying. We needed this extra propane paint to keep the thing burning, but we could use wet sludge. And if you blend that with domestic and industrial sludge, that is a lot drier. So it overall, it improves the efficiency. We're nearly there.
But you don't incinerate only the sludge coming out from the wood scouring or with other sludges?
This is the point, that there isn't sufficient sludge just from wall scouring for it to be economically processed on its own. It would be better to be blended with other sludges, and this is what we're looking at in the next few months. Here we are. So the moisture content was typically about 50% of the sludge was moisture.
Oh. Okay. Thank you.
Okay. Thank you.
Any other questions?
Dr. Pearson, did you look at cogeneration from the energy produced from the flue gases?
We haven't studied the flue gases as yet because the pilot plant, the incineration process was fairly typical of what would happen commercially. But to analyse the flue gases in great detail for the pilot plant would not really simulate what would happen on a full scale. So we're leaving that to the next stage of the project.